just want to do an official welcome and just everything going. Welcome to this CONCRETEFiX, and would you believe 4.1? It means that it's the fourth year that we're doing CONCRETEFiXes, and they've proved to be very successful. People seem to enjoy them, and we certainly reach audiences that we don't reach physically at times. However, watch this space. In a while I'll tell you about two or physical events that are coming up. So more about our speakers and the topic in a while. I'm just going to share with you a screen and actually just a bit of an introduction to Cement and Concrete SA. Let's do that. You're online with Cement and Concrete SA. And now my screen does not seem to work so well. Let me try again. A huge thank you to our partner, which can also be called our sponsor members, that is AfriSam, Lafarge, PPC, and Sapaku. We're also an international partner member of the American Concrete Institute. But I must also mention to you that we've got numerous company members with representative individual members, and we thank everybody who's taken up membership of Cement and Concrete SA. You help us charter the course forward and make sure that we keep on track, that we're doing what our members would like us to do. The membership benefits and membership application forms are available on our website, www.semcon-sa.org.za, or you can contact Natasha Pulse. Her email address is on the screen now for more information if you're interested in becoming a member. There's a wealth of information available from Cement and Concrete SA on our website. The web address is there. We also post on Instagram, and we're available on LinkedIn. So please make sure that you follow us, that you see what is happening. I want to highlight two events, and that's what I said a few moments ago. At the end of February, we've actually got an in-person event in 3 venues. We called it at SemCon 20, hashtag SemCon 2023 at work. And as somebody pointed out, with the spaces in between, that's not a hashtag, but that's the title of our event. We're running it on the 16th of February at Lagoon Beach Hotel in the Western Cape, on Tuesday, the 21st of February at Mount Edgecombe Country Club in KwaZulu-Natal, and the Thursday, the 23rd of February at the Premier Hotel OR Tambo in Gauteng. And what we intend doing there, Brian Perry, our CEO, will be sharing with you what Cement and Concrete SA has been doing, what our focus is, and he's going to be sharing with you about the industry as such. We've also got geographically relevant speakers in all 3 the venues. So in the Western Cape, in KwaZulu-Natal and Gauteng, we find that sometimes the focus is slightly different, dealing with different projects, but the programs will be available on our website quite soon. Please make sure that you book for this conference. It's a 1-day seminar in each of these venues, and it promises to be great. Then something that's just in the stages of being developed now. In August this year, we're going to have a national conference on concrete roads and associated structures. This will be under the auspices of Cement and Concrete SA, the South African Roads Federation, SANRAL, and CSIR. So that is going to be huge, and it's going to be over 2 days, and it will be hosted at the CSIR. So look forward to more information on that. Remember, Cement and Concrete SA, we've got publications for sale. I've just put up some of the cover pages there, and amongst others, the Fulton's Concrete Technology, the 10th edition, which was published last year, and then hot off the press, the 3rd edition, updated edition of Concrete Road Construction Manual was actually delivered to our offices yesterday. It's available for sale. It has been updated to include the COTO specifications and all the new standards and specifications relating to cement and concrete for roads construction. So please make sure that you get your copy. Remember, our quarterly digital magazine, Concrete Baton, is available online on our website. This is the cover page for the November issue. Have a look at it. It's got lots of interesting technical peer-reviewed article, but also industry news. I certainly believe it's worth a read. And Hugh, I can say that because I'm the editor of Concrete Baton, and don't dare disagree with me. And then a reminder that the 2023 education program for a School of Concrete Technology is also available on our website. Professional education to accelerate your career in concrete technology. Talk to our School of Concrete Technology. The contact details are on the program to see how they can charter a path for you in concrete technology. And that is it. That is me done with the introduction to Cement and Concrete SA. Once again, thanks for joining us today, but let's get to the business of today. So as I said, it's CONCRETEFiX 4.1. The title being 3D terrestrial scanning and as-built reality modeling. Our presenters today are Hugh Fraser, Enslin Gardner, and Nina Vermaak. And I'm just briefly going to tell you more about the three of them, and then I'm going to hand over to Hugh. Now, Hugh Fraser is an architect, a professional architect, and he's practiced since 1987. But Hugh has diversified from mere design architect. He was media manager at Paragon Architects. He's highly skilled in implementing communication strategies and a whole host of other things related to the architectural professional. Very interesting person, and I had the pleasure of working with you for a number of years. So I can vouch for the way he runs a workshop and the way he's going to impart the knowledge today. Then our main presenter, I think, is Enslin Gardner. Enslin works for 5D Geo. He's a professional land surveyor with experience in executing cadastral, sectional title, and engineering surveys. He specializes in 3D laser scanning and modeling for a wide variety of professional clients. And our third presenter from 5D Geo is Nina Vermaak. Nina is actually a draftsperson, but she certainly branched out into much more specialized drafting, and amongst others, the photogrammetry and terrestrial laser scanning, underground service detection, and topographical surveys. So I'm going to mute myself now, Hugh. The floor is open. Please, you take us forward. Thank you.
Thank you very much. I've forgotten how much fantastic information is assembled by the Institute and how much I enjoyed the publications. I've learned from past experience about trying to be too clever with screens and that it just runs into problems. So I'm going to try and share my screen now. Hanley, you have to be the class prefect and tell me immediately if you're not seeing something. Because
I should do so.
No, I'm just going to work out which.
We can see your screen, Hugh. That's great.
We slowly get. Okay, so can you see the title page?
Yes, we can.
Okay, great. Thank you very much, everyone, for joining, and thank you very much for the introduction. We were chatting a little bit beforehand, sort of slightly off subject, but the reality is that we're all very aware of how much technology has affected our own world, but we forget how much, we don't really know how much it's affected so many others. I mean, I think the people attending today are largely architects and engineers and professionals within the built environment. So from the architectural side, the developments in CAD from 2D to 3D to modeling to parametric modeling are quite profound. But I think in the world of what I previously knew as a land surveyor, now called geomatics, is quite profound, and the developments have been quite spectacular. So the content will remain with me, but I'll be chatting sometimes in conversation with Insulin and Nina. So basically, 5D Geo is a company, and Ensign will basically, if you can just come in now, Ensign, just talk very briefly about the services that you offer.
Okay. If you can make this full screen, then I'll take us through it.
Ooh, I thought it was full screen. Help me here. What are you using?
I'm still seeing a notes at the bottom, but it's okay. I can just talk through it. It's fine. All right.
Okay.
Okay.
Let me. My mouse doesn't work either.
Okay. No, it's fine. I'll talk so long. Hi, everyone. So starting from the block in the top left, and going through our services that we as 5D Geo deliver. One of the main things we'll be talking about today is high definition terrestrial laser scanning, or TLS for short, and aerial drone mapping. So terrestrial laser scanning is basically capturing an environment in 3D by means of a laser or LiDAR technology. And then what we do is we convert that captured data into a parametric model, which is our second block. That is usually a usable CAD form drawing that the client can then use to extract any measurements or material or any information really that they would require that we captured. And then our next block, we have building information modeling. By that we mean that we usually would provide a base data set of a building, and then hand that over to the architects or engineering team to use for their collaboration. So we would give them an as-built base model that they can then use to base their designs off and to collaborate on ideas and plan for installations. Then we have integrated project delivery. By that we mean that we offer a variety of services, from underground services detection to terrestrial type survey to aerial type survey. And we can integrate the different technologies, the different solutions to basically answer our clients' questions. In the bottom row, we have 2 or 3D modeling for design support. So as you might know, a lot of buildings don't have current or accurate plans. Usually the plans get lost, or there are alterations and they don't update the plans. So before an engineering team would start designing on an existing building, they would need to know what is actually on site, what the site conditions are like. So they would get us in to do an as-built survey, which they can then use to support their designs, to make sure their designs will actually fit in with the current site. And then step after that, and also the block after that, is design validation. So let's say at the end of a construction site, our client would be interested to know how closely to the design plans was the site or the building constructed. So we can do a survey and then do a comparison against the design. In the last block, we have 4D modeling, which is basically adding the time component into our 3D models. So we can show using a number of 3D models scanned at different times, we can show our site or building has changed over time.
So I just want to clarify, are you not seeing a full screen?
I'm not seeing a full screen. I'm still seeing you. Yeah.
Sorry, I am. Then I need to try and sort something out, because I think you're seeing the presenter's view, which is not a good idea.
Yeah.
Let me just try and sort something out here.
Okay.
While
you sort that out, I just want to add to this list of services and deliverables. We also do volume surveys using 3D scanning, and we have a number of cement manufacturer clients where we would go in and scan their gypsum stockpiles, their clinker stockpiles, and so on, to help them track the movement of their raw materials from month to And if you'd like, I can expand on that later.
Okay. I'm going to try something else.
Yeah.
Are you seeing a full screen now?
Yep.
Okay.
Yeah.
Right, it's probably better that I do use two screens. Okay, just to give, as I said, we were talking earlier that the fields, particularly amongst all the built environments, I mean, I think there are probably about 27 careers within the built environment field. So, and they're all being affected by technology. So a 3D BIM model generated from 3D laser scanning will contain all the physical and functional characteristics of the project, including topography, structure, geometry, aesthetics, and materials. A 3D model becomes 4D if a time component is added, and 5D where cost-related information is included. A detailed BIM model extracted from a 3D laser scanning adds value at every project phase, from design through construction and operation to sustainable demolition. High-level BIM implementation provides enhanced risk management, substantial productivity gains, and shortened construction timescales and significant cost savings over the project lifestyle. This presentation is being recorded, so the text, which might seem a little bit overwhelming, can be shared at a later stage. As project design and construction plans take shape, our team can analyze alternatives, identify issues, and solve potential problems before they occur in real life. This greatly reduces risk while saving time and money. BIM models of existing reality allow for making well-informed decisions faster. And as Ensign was saying, and I know this as an architect, it's absolutely astounding how many existing buildings do not have drawings. Our BIM models enable your team to have a constant information exchange among architects, engineers, specialists, developers, contractors, and other parties. It helps your team to make well-informed decisions faster, thereby achieving more effective and efficient design than if our BIM had not been used. The use of our BIM model helps owners make decisions earlier in the design phase. This allows, for example, the MEP engineer to right-size the equipment. In the past, they would add approximately 25% of equipment to cover any changes that happen late in the design phase. By making these decisions early, you're able to size the equipment properly and leave more space for the owner to rent or sell. BIM can also be used for clash detection and to eliminate spatial conflicts, such as areas where the electrical and HVAC designs call for equipment to occupy the same space. Other applications include running scenarios, such as the function of an emergency ventilation system, and energy analysis and modeling. BIM can even model the movement of the sun to assist in conducting daylighting studies and optimizing solar panels. In the construction phase, BIM enables faster responses to design changes or site problems, and it supports planning and cost management. BIM enables teams to assess constructability, fine-tune and communicate construction sequencing and contractor schedule, generate material lists and quantities, and establish material delivery schedules and logistics. Our BIM model also allows owners and facility management teams to manage, plan, and track ongoing maintenance, refurbish, or demolish their facilities more efficiently. We've been doing these presentations for a few months now, and we've changed it quite a lot since we started. Today, we've added various projects because I think there are more engineers involved in today's presentation. And when it's more architectural, we concentrate on that. But the first thing that we are going to look at is the equipment. Ensign, if you just want to talk basically about some of the historical equipment that you've used in the past, and we'll move on to some of the new stuff.
All right, sure. So I've been in the industry for about 10 years, and when I started out, we would use what you call conventional equipment, which is your total stations, your levels, your GPS, and so on. But these days, it's moving more towards mass data capture. So your terrestrial laser scanners, your mobile laser scanners, which is basically a scanner installed onto a car, your drone mapping, and so forth. So it seems as technology is is moving onwards. It seems like things are becoming more automated, and the focus is on capturing a lot of data very quickly. So what we have pictured here is a total station, which still has its place, even though it's considered a conventional tool. Total station we can basically use to measure angles, elevations, and directions very accurately.
So the next slide is an example of a 3D scanner. I went to site with Insyn. So it takes a 26-second scan, and if Ensign, if you'll just go through some of the options, you can see the image, that the choices that are available to the operator on the right, and then Ensign will just explain what the difference, starting with the scan resolution.
Okay. Yeah, so this particular model of scanner gives us 4 options when operating, and the surveyor will adjust those depending on what the purpose of the scan is. The first option to the bottom left, which looks like a grid, would be your scan resolution. And if you look at the first point, that is the density of points per square meter, more commonly referred to as the point spacing. So where you would just want to survey a stockpile, or just want to capture a wall layout and floor to ceiling height, you would set this low. But where you're interested in capturing finer details like let's say wall switches, light fittings, or electrical conduits, you would set this higher so that you obtain higher resolution in your 3D image. The next icon and the next point is scan color. So a lot of our clients just ask us to do the scan, and then they themselves have the capability to work with a point cloud, but they would like the point clouds to be in photorealistic colors to help them interpret the point cloud. So this is where you can enable the scanner to take photos, and it will align the photos and scans to give you a point cloud that looks very realistic. The next icon is a double scan, and this comes in handy when we are doing road surveys, or we are working in a very busy environment like a city center, and there's a lot of foot traffic. So what the scanner would then do is it would do 2 complete scans. It would compare those scans to see which points are not common between them, and then it would remove those points. Those points that we don't want, we refer to as noise, and that's basically our moving objects. And then the fourth icon is just Viz, which it's not really, it's a tool that helps us as surveyors just stitch the data together quicker, and just speeds up the workflow.
So the next one, I went to site with Ensign a couple of months ago, and this was a very typical situation where a developer had bought a building and there were no plans. So what follows is a short sort of 5-minute movie that just, because I knew absolutely nothing, not that I know anything now, but I knew even less then of what happens on a typical scan of a site.
Okay, so right now we are doing a survey of this building and the surrounds. We are doing a 3D scan and a topographical survey. The building is vacant at the moment, so what our architect client wants is reliable as-built drawings, which they can use to eventually repurpose the the building.
There were no reliable drawings, or then, yeah.
With buildings, mostly the drawings either get lost or there are alterations and they don't update the drawings. So maybe what they have right now is not as it is currently standing. So what we have here is a 3D terrestrial laser scanner. This particular one is the Leica RTC 360. What this does is it measures, using this mirror and the laser, all objects in its surrounds. So it basically determines how far objects are away from this position, and from that we get a 3D picture of the laser scanner surrounds. It all depends on intervisibility. In a large open space, the laser scanner can pick up a lot of detail at quite a distance away. But in congested areas, you have to do a number of setups because the laser scanner cannot penetrate objects. It can only pick up what's within its line of sight. So around this building, it's nice and open. Or maybe do 3 setups on the short side, maybe 3 setups on the longer side as well. So you're looking at 9 to 12 setups. For instance, establishing survey points on this site. We use GPS to bring in control from over a kilometer away to establish control on site. Without GPS, using one of these, it would probably take you a day or more just to traverse, bringing control onto site. So yes, we do rely on GPS a lot. From a distance away like this, where you can actually see the roof, the laser scanner will pick it up because the range of this scanner is about 150 meters. So from a setup like this, where you can actually see the apex and the eve of the roof, can pick it up. Issues that we have with this scanner is if there's a lot of movement in the vicinity, it picks up that movement. So people walking about, people that are curious, that want to come see what's happening, those people will be in the data as well. So in areas where there's a lot of movement, there's a lot of cleaning of data to be done. No, that's done by myself, who does the processing in the office. That procedure we call point cloud registration.
Okay.
Not on this particular machine, you don't get a full scan preview, but you get a small preview which you can just use to see whether the data is there. It shows you the point spacing, which means
I'm not gonna pick it up, but anyway, it's fine.
okay. So the point spacing is basically the resolution at which it's scanning. So it's saying at 10 meters away, the point spacing is 12 millimeters. So it measures the point every 12 mils at 10 meters away. Closer than 10 meters, that point spacing will decrease. Before Revit, we need to do point cloud registration, which is the process of taking the individual setups and combining them to form a complete picture of the site.
And does that software come with Leica?
That is a Leica software that we call Leica Cyclone.
It'll take you roughly how long to scan this building?
Scan the interior?
Well, with the exterior and then the interior?
Exterior, an hour.
And then the interior?
Interior, I would say maybe half a day.
You have to go into every space?
Yes, depending on how partitioned it is inside, how congested. I would say up to half a day.
And how long will it take you to develop the point registration?
Also half a day for everything across the whole site.
And how you obviously had to train on this equipment. How long did that take?
I can't say for sure because I did in-house training. There was no formal training for this.
Yeah, like most things, you watch somebody do it.
A lot of institutions don't offer formal training for laser scanning, only conventional land surveying. It took a couple of weeks to get the hang of it, yeah. So in addition to laser scanning, on most sites we need to combine laser scanning with conventional survey methods, such as the total station over there. So what we use that for is we measure certain points that are more difficult to see with a laser scanner, like your smaller services, curb inlets and your fire hydrants, which might be difficult to spot in the scanning data. And we're also measuring benchmarks, which we use to geo-reference our scanning data.
And do you also use that to measure the ground line?
No, contours and natural ground levels we can extract from scanning data. This is a total station. What this does is, from this telescope, it has a laser that it shoots out, which measures distances and angles very accurately. So using this, we can either measure the coordinates of certain features, or we can stake out from a plan where certain features should be located.
So that was the first stage, and then Ensign takes all the equipment, goes back to the office, takes the data, and there are a number of exit points. Ensign, if you would just discuss what is available after the scanning.
Sure. So maybe it might help to carry on. until we get to the slides where I can actually talk us through
All
the
right.
registration. Yeah.
Okay, that's fine. So then this was the generated drawing, and these were examples of the point cloud.
Okay.
Um,
Yeah, I can jump in here, you.
Sure.
So if we would think of the 3D scanning process as building a puzzle picture of the entire site, then we can think of every setup as a piece of the puzzle. So what I'm doing in the software that I mentioned in the video, this is like a cyclone. What I'm doing here is basically building my puzzle. So I start grouping the scans together by adding one puzzle piece or one scan at a time. So this is just a screenshot showing how I am combining two puzzle pieces. You need a certain amount of overlap between the two setups for the software to be able to stitch the scans together. And so we just have to align the two scans using common surfaces. Here you can see we captured a lot of the floor detail, the walls, as well as some of the parking area. And then using the overlapping points, the software will find the best solution to stitch them together. This is the software stitching. Yeah.
A question, if the higher the resolution, the finer the point cloud is going to be. Is that correct?
That's correct. That is correct. Okay, so this is basically the puzzle picture of the site. I did about 20 scans here, which would have taken me approximately an hour. And you can just see the amount of detail that we've captured already. We have the building footprint, the parking area, as well as proximity to surrounding buildings. This is a cross section through the building. So from this, you can see that we can establish wall thicknesses, ceiling and floor levels, also the number of floors.
Yeah.
This is just a top view of the registered point cloud. Okay, so on this satellite image, what we've done is we've marked the points, the survey points, as these little yellow pins. So all these T points, number T1 to 4, are scanning targets that we would use to shift our point cloud into the national WGS 84 coordinate system. So this is useful for clients where they want their drawings to be north orientated, being north towards the top of the screen. So using these common points between the scan point cloud as well as the survey points, we can overlay them and shift our scanning point cloud onto the survey points. In addition, these 4 points would also be used as a verification check on the accuracy of the point cloud. This is an example of one of those points. So typically we would stick a black and white target on a pole, scan it in to determine the center, and then we'd also measure that center using a total station. This is the end result. So this is the north up point cloud that we would hand over to Nina and her team to commence modeling. And if you look closely, you can see the 4 points that we used as checks, as well as the geo reference this point cloud.
So basically the data that has been processed by Ensslin, some architectural firms I know just like to be given the point cloud and like to take it from there onwards. Otherwise, Nina gets the data, and if you'd, I'll just run through the slides, Nina, and you can discuss what you did with the data thereafter.
Hi everyone, Hugh, do you want me to share my screen and I can show them the model itself?
Okay, that's fine. I'll stop sharing now. And then you can share your screen.
Okay, can everyone see my screen?
Yes.
Okay, so this is the point cloud that I get from Ensign after his processing. As you'll see, there's little circles that indicates each setup of the scanner that they made. Just to show you quickly a bit of detail that you can get from the point cloud. Looking at the outside, you got manholes that you can get your ground level from, your curb inlet. From that, we then basically start your base. This would be your basic structural model that I will be showing you. So that's including the model. Generating your floor plans that you can do your planning from. This would be the basement level. You'll be able to look at your setup, look at the column placements. In this case, I think they wanted to look at parking spaces, all that detail. Additional detail that can be captured from the point cloud as well, that if the client requests, we can add onto the model. You'll be able to see the cable trays as well as your fire pipe. And then as well as your mechanical equipment with your ducting as well. Just a side view. Once again, more detail that can be added because the scan data gives you such a big amount of information. Usually we start off with the base model and then as per client's request, we build onto that because we sometimes do find that they don't need all of this and they don't know what to do with everything. So then we do it to client specification. This would be your ground level floor plan. Once again, detail that can be added is your plumbing fixtures, your piping, and just to show the density of our point cloud on these projects, what you can also capture. There you'll have your electrical plugs. There's a plug as well as there. As well as your fire equipment can also then be captured. Then moving up to your ceiling and your slab details. That slab detail can also be included into your model if you want to do a structural analysis or build on, as well as your lighting, what lighting has been used in the building, all your ventilation systems, down to the smallest detail of your sprinkler, your fire sprinkler system as well. Everything's very clear in your point cloud. One of the deliverables as well is then your section, your elevation views, that you can do accurate analysis and planning from that point forward. How much you can still fit in your ceiling voids, what your slab thickness is. And then complete product at the end. If you incorporate your topographical survey with the model, you've got a full layout, accurate layout of your entire site from cadastral boundaries to your building model. And then we can incorporate, and with the survey of the total station, include your manholes, so your services, your underground detection. So you've got a complete overview of your entire site.
Great, thanks, Nina. If you'll stop sharing your screen and then I'll share mine. We're going to talk about two other projects that I think will be of interest. One is a very large hotel in Windhoek that Insulin scanned in during December, and the other one is a more of an engineering type project that was in Tongaat. Insulin, if you would just describe briefly or give an introduction to the project, the Safari Hotel in Windhoek.
Yeah, sure. Yeah, so this hotel was approximately, I think, they had approximately 40,000 square meters of space that we needed to scan. I think it was 500 rooms. And this was for an architectural team where they needed to they needed a as-built plans for a renewal project, essentially. So we flew out, I think, late October, and we spent about 3 weeks on site scanning every room. And the scanner pictured here, the RTC, was our main tool that we used to survey on the site.
And the one thing that was of interest to me that you mentioned is that you had to work around, the hotel was still operating, so you had to work around the fact that there were still guests in and out, so that was an additional kind of hassle. But
yeah,
I mean, obviously you got it.
Yeah, as is the case for most of our projects, access is the biggest issue. So they were going into their busy season, and we could only get access into the guest rooms when the cleaning team went in. So maybe 4 hours a day. That effectively cut our productivity in half. So that was our main issue on this project. Okay, what we are seeing in this picture is we have the RTC on the we have the RTC on the right, and then across the RTC on the left is a smaller scanner known as the BLK, which is perfect for this type of project where you're just scanning small rooms. And then in the middle, we have a 360 camera, which is not what we use to color the point cloud for the client, but we take photos across the site, and those photos will be handed over to the modeling team, Nina's team, to basically use as visual aid to make sure that what they are seeing in the point cloud is what they are modeling. Typically, we would start the scanning outside so that we can get a base data set or skeleton of scans that we can then link the interior scans to the outside. So operator would set up a scanner, you would make sure it's secure, and then you would bubble it before starting to scan. Okay, this is one of the town survey marks that we would find in Windhoek. And you can't see it now, but this is the base of the GPS pole. I spoke about GPS in the video. So what we do is we measure that point very accurately using GPS, and then we make sure we measure common points in the scanning data as well. And then using those two sets of points, we can again shift our point cloud to be in agreement with the national coordinate system and to make sure that the north is facing towards the top of the screen.
Those TSM points, are they still fairly accurate and up to date throughout at least South Africa?
It depends on where you go in South Africa. Some cities don't have them. Position-wise, they're accurate. In terms of elevation above mean sea level, it varies. It varies.
So then the next thing that Ensslin introduced me to was A360, which apparently has been around on Autodesk for a couple of years, which allows clients to look at the drawings, but not and I think comment on them, but not edit in any way. Is that correct? Ensslin, I'll just run through these drawings.
Yeah, that's correct. So we would upload a model to the cloud and then share that with the client to examine, see they are happy. They are able to comment on anything that they think is missing or anything they think looks funny. They can even extract measurements as checks, and then depending on if they made comments, we would update and then upload again and then finalize before delivery.
I mean, there is quite a lot of detail on these renders, but I imagine that you could up the resolution and get even more detail.
Yeah, what we extract or what Nina's team extract just depends on the client requirements. So looking at this, I think our client was very interested in the floor layout, so they could easily extract floor plans. We included services, your plumbing fixtures, lighting, fire equipment.
I mean, as an architect and as somebody who even recently went to measure up a house. I mean, I know that there's probably no way as an architect that I could capture the amount of detail on here. I mean, for example, just to position a light switch, for example, as you can see on the right-hand side, you know, it would take a couple of minutes. The level of detail is quite extraordinary. Oh, I see there are no mirrors in here. Were there no mirrors? But I remember you saying that mirrors can be a bit of an issue.
Mirrors are a problem for the field work, because if the scanner is right in front of the mirror, it will scan the reflection that it sees in the mirror as well. So you would essentially get a mirror image of the room that you are scanning in the data. So mirrors, we usually either have to cover up in the field, or we have to clean them out in post-processing.
Depending on
mirrors are also not something a client to usually ask for, since they are not permanent. I see we've got a question from Heinrich. Does that also apply to water bodies? Yes, water is another issue. So if there are puddles lying on the floor, you could see in your data, you could see that it looks like there's another floor below the floor that you're scanning. So where there's water, those scans also need to be cleaned out, yes. This just shows the amount of detail captured on the ceiling bulkheads, as well as the ceiling services, your lighting fixtures, your smoke detectors, your vents.
Okay, so that's the last one. Actually, I forgot there are actually two more buildings. The one was Fredman Drive building, which is an office building. Ensign, are you happy to carry on talking about it, or do we need any input from Nina?
I can carry on, and then Nina can just give her input. Fredman Drive was a building which our construction contractor client, they basically stripped the building down to its bare concrete shell. And what they then needed was an as-built survey of this building to hand over to the engineering team for BIM collaboration. So we went out once it was stripped down to its concrete shell, we did the scanning, and we provided the client with this 3D model that you see here. Of particular importance was the beams on the underside of the slabs. So trying to capture these beams using conventional methods would have taken weeks, where we captured it using 3D scanning in 2 days.
So I think this is of particular interest to the concrete industry, both the professions and the contractors as well.
Mm-hmm. It's just the image of the point cloud and the 3D model, which was generated from it. And that's a real world photo showing the layout of the beams.
Yeah, we'll come on to heat maps a little bit later, but I think that's also of particular interest.
Mm.
You know, was there anything that you wanted to mention regarding the last project? Nina?
No, I've been in contact with the architect. They still actually phone us because that job is actually on the final stages and they're busy doing the installation of the services, and between HVAC and electrical, they've got millimeters to work with. So that has really helped them in the sense that they're all working off one design and they can all work from each other and work at that millimeter accuracy and save that cost of not buying extra materials.
Yeah.
Okay, so the next one is Tongaat Mall. Esther, if you'd just like to briefly describe the project as well.
Okay. So our client here was a structural engineering firm, and what they needed to do was they needed to know exactly what had been built, since the project had changed hands a couple of times. So they could no longer trust the existing plans on site. So they called us out to come and measure up these steel structures that you see here, for them to then use, extract dimensions, and then finish the design and plan for steel fabrication. So they called us out on site to measure the layout of the steel, the sizing of the steel members, down to the nuts and bolts. So they wanted to see where the nuts and bolts were in the steel members. I think concrete, Nina, can you just confirm that the concrete here was also important, like the change in level across the slab, as well as the support columns on the underside?
Yes.
Yeah.
So those were of particular importance to the client. We actually still do additional for him on this job. I think the one plus point that he's got is he's sitting in his office and someone phones him and questions one area, and he just phones us and we've got the scan data available and he can have his answer within a day, 2 days max, where we don't have to send someone out to site to actually go and measure it up with all those costs involved to that as well.
So Neil, that's a good point, which you've mentioned before, is that all the data is being stored, and even if you're not using it, you can go back into the archive and retrieve information that you hadn't looked at before.
Yes, so there's a lot of you've got to be, just keep in mind, like this is still an active construction site, so you'll have to keep notes and let the client know. You keep dates, timestamp everything, make sure that nothing in that particular area has changed. But if I scanned your house 2 years ago and you come back to me now saying you want additional information, it would more or less be the same, so I can use the same data set as what was captured 2 years ago.
I think, Ensign, this relates to the bolts and the members that you were talking about.
Yeah, so they wanted to see the positioning of the holding down bolts and the size down to the millimeter.
Okay, and then the last thing that we were going to look at was heat maps. The level of accuracy is so high that you can actually detect micro differences in the levels of floors, which I think would have particularly good application for the concrete industry.
Yeah, so although it's called the heat map, it's actually an elevation map. So it allows you to see the change in level across the floor,
Which is quite extraordinary. Okay, I think that's wrapped up our presentation. I mean, I think there are going to be some questions and some discussions. I'm going to stop sharing my screen now.
Well, Nina and Enslin, thank you. As Hugh said, any questions, you can either start speaking. Remember to unmute yourself, or if you want to post it in the chat box. Any questions for the team? It's Ed, go ahead.
If we've got, I'm a structural engineer, and I had a building scanned a year or two ago, or the client did, to try and work out where concrete columns were within brick walls. And it did not prove to be successful because whatever equipment was being used and whatever program was being used got it right maybe 75% of the time, and the other 25% of the time it missed concrete. So a question, the technology that you're using here, when it scans a wall, and say it's a plaster wall, can it differentiate between the different materials within that wall, concrete and brickwork?
Unless it's visible to the eye, it won't be able to. So unless there's a joint or the brick is exposed and you can clearly see the difference between the brick and the concrete, the scanner will not be able to determine where the column lies. So it can't penetrate anything. It just picks up whatever is within a line of sight.
Okay, thank you very much. That clarifies a lot.
So for instance, if the joints are visible, that is where you would increase your point spacing, or decrease your point spacing, increase your scanning resolution to make sure that those joints are visible in your 3D scan.
Yeah, so I'm guessing where he didn't pick up columns, the joints weren't expressed as a rule joint. Yeah, no, that doesn't make a lot of sense now. Thank you.
One of the services that you offer is ground penetrating radar. specifically what Ed's talking about, is it likely in the future that there will be some radar quality or X-ray quality to the scanning? So one could pick up the difference between brick and concrete that had both been plastered over. In other words, going beyond what you've just described.
If it doesn't exist already, it will exist in the near future. What I am aware of is you do get concrete scanning to pick up where the rebar is within concrete. So I'm thinking that if the technology is there, that you can pick up the steel rebar within the concrete, then surely you should be able to, yeah, differentiate between brick and concrete as well. Yeah.
Okay.
Any other questions?
I mean, I've seen their presentation a number of times, obviously, and I'm amazed at the applications. I mean, within architecture, I also subscribe to the Joburg Heritage Portal. I mean, the idea of using this in conservation is quite extraordinary. And also, I mean, countries that I've traveled to in the last couple of years, Egypt and Morocco, historical buildings. But then also there's a whole bunch of other stuff in terms of engineering, non-building engineering has applications as well, I think, which is, I think, quite amazing.
Hi guys,
I
my name is Justin. I'm a civil engineering surveyor here in the Durban area. And I just wanted to add that there is also other equipment in the engineering kind of field where you can actually do real-time comparison of as-built to design. So I use a Trimble X7 scanner. I think it's accurate to about 2 millimeters. The scanner, that Leica scanner that you guys got, the TC, that one there is accurate to about 1.9 millimeters, and then your BLK is accurate to about 4 mils. But what there's a slight difference between the X7 and the TC is that the X7 allows you to do a resection, which allows you to geolocate the scanner itself. And at that point, when you do your scan, your point cloud is already registered, it's already geolocated. And that actually allows you to also, say, for example, guys are busy building columns and stuff on a building, you can actually in real time scan that and compare it to a 3D Revit model. So yeah, I'm also just getting into scanning, and I'm exploring all the functionalities of the different types of equipment and what's available you know, in industry. And yeah, that is something that I've found, and I just wanted to know, are you guys so you guys are based in Joburg, and I wanted to know, like, is there any opportunities for somebody like me to collaborate with you guys?
Yeah, Justin, open to any partnership, any collaboration. I just want to say, it's impressive, the work you're doing, and it seems to be a direction that things are moving in, automation and getting results quicker, also doing things more accurately. So eventually we'll be able to do everything in the field on a tablet, and then after that, we won't even need to be in the field. We can just send out something to do it automatically. But yeah, so impressive.
There's a question: how does Nina and the process team develop the scan into Revit? Is it generated or conventionally modeled by tracing?
It's conventionally modeled. At the moment, we haven't found any reliable software to extract from the point cloud automatically. At the moment, you still need that experienced eye to look at the point cloud, interpret it, and then trace over it. And then at the end, look at the model against photos to make sure that what you're seeing in Revit is actually what there is on site.
There is some software that we use to automate piping, your steelwork, but I've tested how many softwares, but I haven't actually gotten one that is 100% or that I'm happy with. Maybe my standard is just too high for software, but you still do need the human eye to interpolate. And also I've got photos that support me as well, that I can go and have a look at materials. I don't know if that will ever be able to be fully automated.
The one thing that it came up when I was working at Paragon Architects is because the software is all American and they're not particularly kind of open to this, but there was a problem with generating humans, particularly people of color, because we would buy figures from a library. So I put it to 5D Geo, not that they've taken it up with any sort of zeal, but the idea of scanning people at a very high resolution, could that technically be done, Ensslin?
Scanning people in color, yes.
So I think there's a growth industry there. I think you should start your staff and the Christmas card.
Yeah, I think the application for 3D scanning and modeling it's just limited by our imagination. So to me, it sounds like you could scan a person or even an environment in color and use that to generate, for instance, a movie set or something, or game environment or something.
No, absolutely. I mean, we spoke about this at the beginning, within architecture and engineering, Lumion, Unreal, 3D Studio Max, these are all softwares that we think are designed for us. But in fact, I know that when Notre Dame burnt down, there was a woman who had scanned the building a couple of years earlier for gaming that was used in the reconstruction of the church.
Any more questions?
I would just like to also know a list of softwares that a person should be interested in acquiring to give the full service, as in from scanning through point cloud registrations to modeling to final deliverables. What's the best set of like software collaborations, because you also have to collaborate between softwares. I'm more accustomed using the Trimbles, so I use RealWorks to do my registrations and all of that other jazz, but I'm also looking to get myself into the Revit modeling part of it. Are there any other softwares that one would require to sort of achieve the ultimate goal of every architect engineer that might require services? So I know of Cyclone, that's Leica's software. I just want to know if there's, so my idea is RealWorks as a replacement to Cyclone, and then Revit modeling. Revit with their recap. What's it? I think it's photo recap. Yeah, Revit recap. Are there any other softwares that one should look at acquiring? Like Nina spoke about software to do the piping. So does Revit not do the piping? Do you need other software to do the piping?
So Revit, you do have piping in Revit, but that would be a manual process. You get these, I can honestly tell you, through software hunting day by day, you need about 50,000 softwares to be able to get to your top-notch complete, because one software specializes in one aspect, but not the other. So it is, I mean, we use MicroStation, we use Autodesk, we use Cyclone, we use that's what makes it so hard, is no one's combining into everything for one complete ideal package. You're still going to and it becomes quite costly if you're looking at all of them. So you kind of have to make sure you stay in what you want to specialize in.
Now, okay, understood.
I just want to add to
Thanks,
that.
Mike.
So I just want to add to that. So Justin, so it's always better to try and stay in your native software environment.
Comfort zone.
So where you are using Trimble software would suit you better because it's most compatible with your scanner. We're using Leica, so we use Leica software. And then the industry standard for deliverables seem to be more towards Autodesk. So we usually deliver in Autodesk DWG or RVT or RCP. And that seems to be interchangeable. And a lot of people seem to be able to use that. Yeah.
Okay, can I ask that if you've got any more questions of this nature, that you most probably directed directly to Enslin, to Nina, or to Hugh. Hugh, in closing, have you got contact details available if people want to get in touch with any of you?
I think there was a problem with the website. I was just trying to get onto it, and for some reason I can't get through onto 5D Geo, but they can contact any of us on the details that would have been sent out with the invitation, and I'll find out what's up with them 5D Geo. But they are on Instagram as well, so apparently it's very hip to communicate. I mean, I was in Bucharest last year and I lost my wallet, and I never look at Instagram messaging, and somebody sent me a message on Instagram to say they'd found my wallet. So yeah, it's we can all be teenagers and
so for the young people amongst the audience today, look at Instagram, find 5D Geo, find the speakers there. For the older visitors today, contact us at Cement and Concrete SA. We'll pass on the contact details to you. We've got email addresses, the old and trusted email addresses for the three speakers. So I think with your permission, we're going to call it a day. Thank you so much, Hugh. Thank you, Enslin. Thank you, Nina, for sharing your expertise with us. You know, we live very much in the concrete world as material specialists. We look at the concrete from a different perspective. Today, you've given us a new view, or for many of our online guests today, something different to think of, something that we don't commonly think about. So thanks again for sharing with us today. Thank you for joining us, and thank you to everybody who logged in and who stayed logged in. There won't be a CONCRETEfiX in February. We're going to do the physical convention on those 3 days that I've mentioned earlier on. Please look at our website for any more information. But thank you, Hugh. Thank you, Enslin. Thank you, Nina.
Thank you,
Take care,
Thank you.
everybody.
Thank you.